In this video, we're looking at solving linear inequalities. So we're doing this because we want to be able to solve mathematical statements that don't necessarily contain an equals sign. It can be very useful in some areas of maths. So our success criteria here is we can apply the rules of algebra to the inequalities, solve our inequalities for the unknown value, usually x, and we can represent that solution using a number line. So what we're talking about is an inequality is a mathematical statement where it's instead of having an equals sign, it has an inequality symbol. So our inequality symbols are greater than, less than, and are greater than or equals to, less than or equals to. So we've got greater, less, greater or equal, less or equal. So if I had x and then our symbol and y, this means x is greater than y. Okay, so think about your little like crocodile jaws, the side where it's got the big gap, whatever side that's on, that thing that's on that side is bigger than the other side. And if you've got the extra line underneath, like we have here, that just means we've sort of combined the equals sign and the inequality. So we're saying the value can be less than that, or it can be equal to that. So an example we've got here is 2x plus 1 is less than 4. So when we solve it, what we're saying is we're answering the question of which numbers, so what values of x, satisfy the property of 2x plus 1 being less than 4. You could trial and error. It would take a very long time to find the actual point at which the number line should start. But I mean, if you were to put in x equals -1, you'd have 2 times -1 plus 1 is less than 4. So that's going to be -2 plus 1 is less than 4. So -1 is less than 4. And yes, -1 is less than 4. So we know at least -1 satisfies that inequality. But the way we're going to do this, basically, so this is our first example here. We want to solve the inequality 2x plus 1 is less than 4. You're basically going to treat that inequality sign as if it's an equals sign. 99% of the time, you're treating it just like an equals sign and basically rearranging your equation. There's only one special case where that's not the case, and I'll get to that in another example. But so here, we would subtract 1 from both sides. So we'd have 2x is less than 4 minus 1, which is 3. And then we're going to divide both sides by 2 to get x by itself. So x is less than 2 over 3. Now I've got a nice number line here, so we're going to represent our solution of x being less than 2 on 3 on this number line. Except that I got this wrong, and it's 3 on 2. I know how maths works. So we're going to find the point 3 on 2. So that's 1.5. So that's going to be about here. I'm going to draw a little circle. Okay, that's representing that it's the end of our number line. Now we know x is less than that. So our line is going to extend that way. And you put an arrow on to say that it's going to keep going that way, because there is an infinite number of solutions. As long as the value of x is less than 3 on 2, they're all going to be valid. So for our second example, we want to solve the inequality 3 minus 2x is less than or equal to 4. In terms of solving, this starts exactly the same. I would subtract 3 from both sides. So we'd have -2x is less than or equal to 1. Now, there is a special case here. So we would be dividing by -2, okay? When you divide by a negative, your inequality flips the other way, okay? So So in this case, if we divide by -2, this inequality here is going to flip round this way. So that's just a special rule when working with inequalities. The only thing that's different to the rules of algebra is that when you divide by a negative number, or multiply by a negative number for that matter, so divide or multiply, add that in. So when you divide or multiply by a negative number, your inequality sign is going to flip the other way to whatever it was. So in this case, we've decided that x is greater than or equal to -1/2. So if I had my number line, 0, -1, -2, 1, 2, we would draw our circle at -1/2, so -1/2. Now, you notice in our first example, we drew an open circle. This is because x can never actually equal 3/2, right? It's always going to be less than it. It can go right up to the border of it. It can never equal it. Here, in our second example, x can equal -1/2. So what we're going to do is we're actually going to fill in our little circle. So when it is filled in, that represents that the inequality can equal that value. But x is going to be greater than or equal to -1/2. So our line extends out. Whoa, let's draw a straight line. Our line extends out that way with its arrow. Okay. Example 3, a little bit more complex. We've got the fractions in there. So nothing super hard, but that little bit harder than your one-step equations. So we're going to multiply both sides by 5 and both sides by 3 to get rid of those fractions so that we're cancelling out. So we're effectively multiplying by 15, but we're going to have 3 outside of 2x plus 3 is greater than 5 outside of 3 minus 4x, and that 2 gets multiplied by 15 is going to become 30. So same principles apply for setting out. You want your inequality to be lined up down the page, just like you would with an equals sign. We're going to expand these brackets to be 6x plus 9 is greater than 15 minus 20x plus 30. So 6x plus 9 is greater than -20x plus 45. Let's take the 9 away. 6x is greater than -20x. 45 minus 9 is 36. And then we'll add the 20. So 26x is greater than 36. X is going to be greater than 36 over 26, which we can simplify down to be 18 over 13. We could put that on a number line, but I think you guys get the gist of that one. This would have an open circle rather than a closed one because it cannot be equal. So it would just have the hollow dot, not a colored in dot. So from success criteria, we can, let's go back up and look at that. We can apply the rules of algebra. We can solve our inequalities for the unknown value, and we can represent those solutions on a number line.